adding, subtracting, and multiplying polynomials. So the first section we have addition and subtraction. So for addition, you're pretty much just combining all the like terms together. We don't really need to worry about the parentheses too much because if you multiply in a positive 1, you're not really changing anything. So yes, there is a positive 1 here in front of the right parentheses, but if you multiply this in, you still get x squared. So this is still x to the third. You still get a negative 10x squared. And 1 times 8 is still an 8. So nothing is really changing when you multiply through by a positive 1. So when you're adding, we can kind of ignore the parentheses around these different polynomials. So now we can go ahead and combine like terms together. So 3x to the third plus an x to the third make a total of 4x to the third. 2x squared plus a negative 10x squared makes negative 8x squared. 1x, and then there is no x on the right-hand side, so we don't have a like term to combine that with. And then negative 7 and plus 8 can be combined up to be a positive 1. And so when we finalize our answers here, we always write this in highest degree to lowest. So the degree is the highest exponent. And so we always write these from highest exponent down to lowest. So 3, 2, 1, and then no exponent at all on the constant. So subtraction is pretty much the same idea. The only difference is when you do subtraction, if you multiply through by a negative 1, now you're changing this right side polynomial. So negative 1 times 2x to the third is negative 2x to the third. Negative 1 times 6x squared is a negative 6x squared. Negative 1 times negative x is positive x, and negative 1 times positive 1 is negative 1. So with subtraction, you have to remember to distribute the negative 1 that is indicating subtraction. Otherwise, you will end up with the wrong signs on your terms for your polynomial. Now that you have distributed out the negative 1 in the front, we can go ahead and combine like terms together. 8x to the third and negative 2x to the third creates 6x to the third. Negative 3x squared and negative 6x squared make negative 9x squared. Negative 2x and a positive x makes negative x. And 9 plus a negative 1 makes positive 8. And again, we write it down from highest exponent to lowest. That is our standard form. So this is the finalized solution. Pause the video, try out examples 3 and 4. And here are your solutions for 3 and 4. Notice on 4, the negative 1 was only distributed to the middle parentheses because the right one had an addition sign, so we did not need to change the first or the last set of parentheses. Now let's look at number 5. Write a polynomial that will represent the perimeter of the composite figure below. So first of all, we have to remember that perimeter means adding all sides. Now, it's a composite figure, so this is made up of more than one shape. So we can kind of think of a line here creating rectangle 1, and this is rectangle 2. And so trying to find rectangle 1, we're almost there. I do know, however, that this 2x plus 3 is also this space here. So this is 2x plus 3 as well. I also know that this green 4x squared minus 3x minus 8 is also this green distance over here. We have to figure out the only side we're missing is we're missing this piece here. But I know that that piece at the bottom is made up of this. Basically, it's this long piece here if I take out this piece down here. So I'm going to find that question mark first. So that's the first thing I'm going to do, is I'm going to find the missing side, because I need all the sides in order to find perimeter. And so I know that the missing side is going to be the top 3x squared plus 2x minus 1 minus x squared plus 4. Because I do know that this is the entire side, but if I subtract just from here to here, all I'm going to be left with is the blue question mark space. And so if I figure out what this is, so this will be negative x squared minus 4 because we distribute out the negative. And if I combine like terms, we get 3x squared minus an x squared, so we get 2x squared, 2x, there is no more x's, and then negative 1 and negative 4 make negative 5. So that is this missing question mark piece here, 2x squared plus 2x minus 5. Now that we have all of the sides accounted for, we can simply combine like terms. So I'm going to write these vertically. So step 2 is find the perimeter. Now that I have all the sides, let's find the perimeter. The key to this one is finding a way to organize your work. So I'm going to write these vertically, and I'm going to line up all of their like terms. So 3x squared plus 2x minus 1. Then we have the 2x plus 3. Then we have the x squared plus 4. Then we have that green underlined of 4x squared minus 3x minus 8. We have the red question mark that we found from the step 1, 2x squared plus 2x minus 5. We have another green, and we have one more red, 2x plus 3. And now we're simply going to add all of these pieces together. All of your constants, you get negative 12. Add all of our x's. We have 2, 4, 6, 8, 7, 6, 5, 4, 3, 2. So we have 2x here. And then add all of our x squareds. We have 3, 4, 8, 9, 10, 11, 12, 13, 14. So our final perimeter is 14x squared plus 2x minus 12. So the hardest part about this is finding a way to organize all of your math. Now let's look at multiplication. So multiplying polynomial expressions is distribute as many times as necessary. If you have something that is squared or cubed, please make sure you expand everything out to make sure all the terms are being multiplied together. So example number 6, we have a monomial, so something with a single term, a monomial multiplied to a 4 terms, 1, 2, 3, 4 termed polynomial. Now, we know this is multiplication because there's nothing in the middle here that says plus or minus or division. So having two things next to each other indicates multiplication. So simply distribute. And remember, when you distribute, the exponents of like bases will add. When you multiply, exponents will add together. So 2x squared times 2x to the third, the coefficients, 2 times 2 makes 4. X squared times x to the third makes x to the fifth. And then 2x squared times a negative x squared, you get negative 2x to the fourth. 2x squared times a 3x, you get a positive 6x to the third. And 2x squared times a negative 5, you get negative 10x squared. And again, make sure your polynomial is written from highest exponent all the way down to the lowest. And this is your simplified product. So for number 7, we have 2c minus 1 cubed. So we need to make sure we expand this out. We cannot just say that this is 2c cubed and 1 cubed. It doesn't work like that. We need to actually expand this out. When you have something that is cubed, you have something times itself 3 times. 1, 2, and 3. So we first need to multiply these two together first. So 2c times 2c is 4c squared. 2c times negative 1 is negative 2c. Negative 1 times 2c is negative 2c. Negative 1 times negative 1 is positive 1. But we still have 2c minus 1 out to the right still being multiplied. Before we do another round of multiplication, let's add up what we can. So I can combine the two middle 2c's to make negative 4c. And this will make our multiplications a little bit simpler. And now we multiply again. So we have, I'm going to go backwards. I'm going to do 2c times 4c squared. 2c times 4c squared, which gives us 8c to the third. 2c times negative 4c, which makes negative 8c squared. 2c times 1, which makes 2c. And do it all over again with the negative 1. Negative 1 times 4c squared is negative 4c squared. Negative 1 times negative 4c is a positive 4c. And negative 1 times 1 makes negative 1. Finally, add your like terms. 8c to the third is, there's no like terms. Negative 8c squared and negative 4c squared make negative 12c squared. 2c and 4c combine to make 8c. And negative 1 also does not have a like term. So for number 8, you actually have to set this problem up yourself and then work through it to simplify down. So it says find the volume of the rectangular prism below. So first thing, the volume of a rectangular prism is found by multiplying the length, the width, and the height. Because you're multiplying, it doesn't matter what you call length, width, and height. So we can call this guy length, we can call this one width, and we'll call this one height. So to find your volume, you're simply going to multiply the length, 2x plus 2, times the width of x plus 1, times the height of x plus 3. So pause the video and multiply this out and get it into its simplest form. Polynomial that represents the volume of the rectangular prism above. So let's look at number 9. You make a tiny tin box by cutting x inches and let's look at number 9. You make a tiny tin box by cutting x inches by x inches squares off the corners of a rectangle that is 12 inches by 6 inches and then folding up each side. The plan for the box is shown. What polynomial represents the volume of this box? So the original box here, the whole box, or tin, I guess I should say, is the length is 12 by 6. So what we're going to do is we are going to actually cut out those little squares on the corners and we're going to create a box that folds up. So what we're doing is we are creating this box here that will fold upwards. And it's going to have an open top. So this is the box that we're going to create. Now to do that, we have to take out these little pieces here and fold up the corners. And so what we need is we need to figure out what these sides are. So this here on the inside, right here, the base of my box is going to be 12 minus the 2 x's that I'm cutting off, because I'm going to cut this piece off and this piece off. Now on the other side, similarly, this here is actually going to be 6 minus 2x, because again, you're cutting off this piece here and this piece here. So the dimensions of the box so far is we have 12 minus 2x, and we have 6 minus 2x as the length and the width of the box. We're missing our height. Well, if this is the side of the box, that's got to come from here, that piece that was taken out, that little square. And so the height is actually x. Whatever you cut off, that's going to be your height of your box. Now that I know the length, the width, and the height, we can find the volume of my box. So for the volume of the box, again, length times width times height, you're going to set up length, which is 12 minus 2x, times the width, 6 minus 2x, times the height of x. And then everything gets multiplied together. So take a minute, pause the video, multiply this out, and see what the volume of this box is. And here is the volume of the box.